GPS and delineation of enumeration areas. Okay, so there will be a first part where we're gonna make an overview about how the GPS works, what the enumeration area is for, and well, just a theoretical interview. We're trying to go fast because I imagine that all of you know about this, but just to refresh and to be sure that we are all in the same page. Okay. Working with plots and households. Okay. Here in the region, as far as SDD knows, well, we know very well. There has been currently there are two methodologies for statistical data collection, or for, let's say, household listing, because with PAPI, when we are running the sensors, we don't usually go with the GPS in the field. So typically, there's GPS plus PAPI. Okay, we had a questionnaire in paper, and the geospatial component, the household location, the agriculture plot location and surface, was collected with a GPS unit. Okay, it was typically used to conduct household listing, as I was saying, during the census, during the surveys. Well, it depends, but we don't usually add this geospatial component. And in order to connect what we are collecting with the GPS with information entered in the paper tables, we need to enter a household ID in the GPS unit and in the paper. And then during the data entry, we need to connect the GPS points files with the information data using that household ID code. Tablets. Now, many of the countries in the region, we have moved to CAPI, Computer-Assisted Personal Interview, where the main difference, if we compare it with GPS plus PAPI, is that the geospatial data and the questionnaire data, it's already linked, okay, under the CAPI application. Since we are using tablets to fill our questionnaire, and we are using the same device to locate the household location, to locate the land plot, to locate whatever we are trying to locate. Everything is linked, so there's no data entry anymore. There's no household ID because it's already in the same line of our database. We have, for example, name, surface, crop, number of people, number of male, number of females, and at the end we have coordinates. Everything is integrated. There's no data manipulation to connect both databases, okay, both data. So the advantage, data quality gets improved because there's no data entry, there's no errors, there's no human manipulation, there's no I'm not making mistakes entering the household ID, etc. Okay, and that means that we are much faster when we want on releasing the data sets. Okay, we don't have months of data entry from paper to the system. Okay, either if we are using Stata, CS Pro, but there's human manipulation. And when we have human manipulation, that means that we have more time consumed, and we have errors. Okay, so it's more secure because we don't have questionnaires, papers that get lost in the field, that get don't know. Well, we have, don't know, if it's raining and we have the questionnaires, we're loading the questionnaires in the pickup truck, or some boxes get lost in the office. So once I finish my questionnaire, I upload it, if I can, into the server, and there it's safe. Okay. And well, let's talk about the disadvantage. Okay, for the moment, the accuracy provided by a tablet, by Android or mobile smartphone, the built-in or the integrated GPS receptor, for the moment, is not. It gets worse accuracy than the GPS units we are usually using. Let's say that for sensors data collection, we usually use these recreational GPS units. They are not professional. They are not for topographic works, or any other. So recreational unit provides the best accuracy. It's in between 3 and 5 meters. For tablets and smartphones, it's 10-20 meters. So it's coarse. If you imagine that you have you have to plot a house, you usually move like 3, 5, 6 meters further to get good signal, because if you have a roof, if you have the canopy, you have to avoid that. And then you have 10-20 meters. Okay, you would say, oh, that's a big disadvantage. No, it's something that that we can improve. This GPS antennas that can be connected via Bluetooth, and you can get 3 meters, even 60 centimeters accuracy. But because you are not using the GPS integrated in the tablet, it's an external. It's like if you have a GPS unit connected to your tablet, and but well, that increases a lot the cost. And I always say one thing: we are not gonna build a bridge with those GPS points. We're just trying to locate a household. We are trying to locate. I don't want some. People ask me when we finish the listing, why don't you put the points on top of the roofs, no? And it's like, okay, sometimes if you have an isolated dwelling in the middle of a rural area, and you can manage to put the point on top of the roof. But the reason why we gathering points, it's like, well, first of all, because we are going to estimate the workload for the sensors or for other activities. But in case of the surveys, okay, that we are going to select a part of the households listed in the household listing or in the census. So, for example, if we are going to select, we're going to make a gender survey. So we select households with women with age in between 15 and 45, okay? So we random select under those conditions, and we say, okay, the people who's gonna work in the field has to go to these 4 households in the EA. If you have an accuracy of 10 meters, you have a rough location of the household and the name of the head of the household. You might find where the household is located with this information, okay? If you want to locate exactly where don't know, if for other, but in general, for stats data collection, we don't need that much accuracy, okay? So the advantage of having everything integrated in the tablet, it it works to move on tablets even if we lose accuracy on the point location. Okay, our points, the quality of the points is a bit worse, but we don't miss any point. Sometimes when we were doing listing, we were missing like hundreds of points that we don't have any location because the GPX files were lost, or we were not able to connect them because the codes didn't match. Okay, and indeed with CAPI we can correct in real time. So in overall the quality is much better using CAPI, even if we have less accuracy. So GPS accuracy, and this is useful for both GPS, recreational GPS units, and tablets. Okay, it's the same. The only difference is within our smartphone we have a very small GPS antenna and GPS receptor. Okay, so to know once we switch on the GPS, it's not just a matter of receive signal from satellites. Okay, the GPS is downloading any other dataset, almanacs, the initial location, the ephemeris, is data in relation with the position of the satellites. Okay, so the more time, well, when we switch on a GPS that has not been used for a while, we will need to wait like 10-20 minutes, okay, to allow it to download all that information from the GPS. That data allows the GPS to calculate, to estimate its position. Okay, it's not just a matter of receiving signal, it has to download the information that helps the GPS to calculate the position. Well, overall, roughly, best management practices to improve the accuracy. Apart from when we start the GPS, a GPS that has moved hundreds of kilometers. Well, I think that in the next module we will go in deep. Apart from that, in general, when we are in the field, working in the field, we never take a plot inside a building because there's no signal arriving, or the signal that we have is a signal that it has been reflecting, so the quality is not going to be good. We try to be far from high buildings, trees, to be under the shade. The less we can see the sky, the worse is our signal. And well, the basic rule, be sure that you can see the sky. This is for enumerators, okay? This is more or less the part of how do we collect or the element, the geospatial element in census in stats data collection. Okay, enumeration area. Okay, definition. Okay, this is are the operational geographic units for the collection of census data and are defined early in the census process. Okay, so it's simple pseudo administrative units that we use in census and agriculture, in stats office and agriculture and forestry to organize the workload. Okay, it helps us to it's a matter of subdivide village units or village districts, okay, in smaller units that we can manage, okay, that we use to manage the workload and so on, okay. Well, different characteristics. They have to be exclusive, okay. There's no overlaps, there's no doubles. They are unique. Which means that they have unique codes and unique locations. They cannot overlap, okay? And they are exhaustive, which means that they cover the whole country. In some of the EA frameworks we have in the Pacific, we tend to we ignore the regions that they have no dwellings there. This is something that we need to improve, because whenever there's a new dwelling constructed out of our current enumeration area framework, we have a problem, because we need to create a new one, and it's hard to connect afterwards with the old enumeration area framework. So it's better to have probably big enumeration area polygons, even if there's zones that they are not populated, and then we can deal with these big EAs by preparing maps zooming in the populated areas. Okay, but the problem is that if we afterwards we have new dwellings built, those dwellings can be missed because they are out of the boundaries of our enumeration area framework. To have boundaries that they are easily identifiable on the ground, which means that we tend to use roads, we tend to use landmarks, we tend to use buildings, okay, to define our boundaries, okay? That makes the life of the enumerators easier. That helps them to read the maps, okay, and to know the boundaries where they have of the enumeration area that they have to cover. They help them to, if you have a road, which is the limit of the enumerator area, you know that on your side of the road you have to cover all the households there, okay, and the other side of the road, it belongs to the other enumerator, okay, so there's no conflict. That they are consistent with the administrative hierarchy, which means that if I have this district, this is D1, all my EAs, the external boundaries, they have to match with the administrative level above. Okay, there's not a good practice this is not a good practice, because if after all we want to aggregate data at district level, the population in district 1, how do I manage with this EA, which is in both districts at the same time, okay? So when we delineate enumeration areas, they have to match with the upper official administrative level. And that they have populations with the same size. That like this we are sure that one enumerator can cover one enumeration area during the census night. This is a very important, okay, because we have noticed that now with CAPI that you can monitor data in real time, okay? For us and for the supervisors, it's easier to detect errors if you have only one enumerator working on the EA. First. Second, you never know whether you are missing a household or not. If you have multiple enumerators working the same enumeration area, hey, did you cover that household? Imagine that you have 3 enumerators and there's 2 talking each other in the field. Did you cover that household? No, maybe it's the other who's gonna cover. You can never know. So it's impossible to know. While if we have only one enumerator, you know that that enumerator assigned to the enumeration area number 2 has to code all the households with EA code number 2. So if Peter, the enumerator Peter Foster assigned to the enumeration area number 2, if he assigned a household with EA number 3, you know that there's an error. So it's a smart way to detect errors. Okay, Peter Foster just can assign households in EA number 2. If he enter another EA code, I have the error. If I have William, Peter, and John in the same EA, I don't know. Okay. So the enumeration areas are flexible. We can modify them. Okay. It's better to modify following some rules. Okay, if we want to have EA frameworks that are compatible, my version of the 2000 it's compatible with the 2010 and it's compatible with the 2020, because I want to make population comparisons between the different years. Okay, if you follow some rules, you can make them compatible, but still we can modify them. Okay, that they cope the needs of other government departments, that are useful for other type of census or data collection, that are large enough to guarantee data privacy. There's no point to have a enumeration area with only 2 households, because we can, well, we break the rules of confidentiality. But at the same time, as I was mentioning, they are small enough that we are sure that an enumerator is going to be able to handle it during the census. Okay? So here I have put a few examples about enumeration area delineation. So what can be improved? So let's talk a little bit. So you see this enumeration area, and what would you improve in the boundaries? So are they following landmark? So if you, as a enumerator, okay, you have your paper map. A paper map, this is something that we are gonna learn to produce during this training. But you have to put in the shoes of the enumerator. You're hitting the field. You have your map. You have this. Would you be able to read the map and say and understand where the boundaries are? Here I'm following the road. So yep. Here, okay. Here, if I have a household here, but I have the other enumerator working here, which is saying, well, maybe my colleague is going to cover the households. Okay? And this enumerator says, I'm within my boundaries. I'm not going to enumerate that house. Okay? So we have to try to those limits to get EA boundaries as clean as we can. Okay? For example, here where we don't have choice, this is a good one. I don't have roads. I don't have a well-defined road. Sometimes here in the region, there's no. The urban areas are very tough to when you want to delineate enumeration areas in crowded urban areas, in Majuro, South Tarawa, it's challenging, okay? But you can use, for example, this tennis court, and the enumerator says, okay, from this tennis court, the straight way, I can see the limit, okay? Actually, it was the tennis court, what I wanted to highlight. For example, this one. Wait, can you see more or less? So we have this enumeration area, and then we have this hotel. Okay? Depending on the type of census, we don't enumerate hotels. Okay? Because we're going to, in a survey, we are not going to select a hotel. Okay? But we should be including this piece of land into the enumeration area, because we might have some of the workers of the hotel living permanently there, and we will miss them if we don't include the hotel into the enumeration area. That's why we have to cover the whole surface. Okay? Then, for example, the roads are very nice, and the limits are easy to understand. We have the coast, we have the roads, easy. This one. So if I am the enumerator, poof, this is very hard for them. So we probably are gonna have problems or households missing or households double count all across those boundaries. Why don't we use these roads? Okay? Why don't you just split here, take this road and say from the road to the coast, 1 EA. Okay? Even if, so that's a little bit the way. This is this is Quadjalane. So this is hard, but still we can use roads, streets, big buildings, gas stations, facilities to help the enumerator to read the limits of the boundary. Okay? This is Vanuatu. So here is Port Vila, which is a good example of well, maybe we could clean those limits, but it's okay. And here, why, if we have these roads, are we using those, how to say, arbitrary limits? Okay, because maybe at the time they delineate the enumeration area, there was no satellite image available. So that's why we have, but now we have satellite image available for free. This is something that we need to improve, okay? Because it will improve our data quality. Then the codes have to be, we need a unique identifier for the enumeration areas. We need that those code follows a hierarchy. Better if we use well, the administrative level code hierarchy. So we go island 1, district 1, village 1. So it's 01, 001, 0001, and then EA. Okay. So the example of Fiji, we have an EA which is 107.00140, which is the Tikina 107. But the point is that reading the EA code, and this is important, when we create the maps and when we label EAs, it's better to keep the whole EA, because like this we don't have to add information about which island or which village or which district. Okay, so reading that code, we know that it belongs to Tikina 107 and that EA it's located in province number 1. Okay, so this is the example in a map. So we have province in red boundary, the Tikina blue boundary, okay? And then we go to the administrative level below, where we have the Tikina with red boundaries and the EA in blue boundaries. So reading that code, I know in which Tikina and province is this EA located. Well, this is something that all of you knows perfectly, but just to refresh. and consistency between past sensors EA frameworks. This is tricky, okay? But we need to make our best trying to make all the EA frameworks compatible. We miss a lot of value in our data if we start a sensors and we start an EA framework from scratch. Okay, if we don't have choice because our EA boundary is getting deprecated or we cannot hit the field anymore because the boundaries are not very good, okay, let's go and review that. But we will try to keep the same structure or to keep the spatial relationship between the different versions, okay? It's true that now with CAPI, since we are collecting at point level in sensors, we were collecting at EA level. So all the data we were collecting was integrated in that polygon. When we were changing the polygon, it was a mess. You couldn't reconnect, you could not compare population or another type of indicators at EA level because the polygons were different, so there was not possibility. Now with CAPI, we can convert data because it's a point level. So we can reconvert data to the previous EA framework just by overlapping the point with the 2000 EA framework and say, okay, this point belongs to the EA1 from 2000 EA framework. And now we will be able to compare. So this is, before was a huge problem. Since we are using CAPI, not that much. We can be more flexible, okay? If we want to review our EA frameworks. So let's go to the exercise. So what are we gonna do now? Okay, we are in module 2, so all the elements you need for this exercise is in the module 2 folder, okay? We are going to import point layers from different data sources, from GPS, from CSV, I think, well. And then we are going to edit point layers. We are gonna change the location. And we are going to create from scratch a enumeration area polygon, okay? So, just a quick tip, okay? Make sure that, well, here in the exercise is already, everything is working, crossing fingers. So we have to be sure that the coordinates are in decimal degrees and not in degree minutes sensors. When we collect data from GPS, we can, well, you can choose different ways of writing or of writing the decimal units. So we always set our GPS units to be used in decimal degrees. You can convert from degrees, minutes, and seconds, but it's a pain, okay? So if we collect the right coordinates in the right coordinates format from the beginning, the better. But in these exercises, it's good. And QGIS is not able to import Excel files. So sometimes we are not very, we don't have skills enough, or we don't like to work with tablets within QGIS. So I prefer to recommend of working on Excel when you are working with tables, and then know very well how to import and how to connect those Excel files or those tables to your polygons or point layers, okay? This is something that we're gonna learn afterwards. So if you don't feel very comfortable working with tables in QGIS, no problem. You export your table into Excel, You do whatever you want, and then you reconnect it back. Okay. So the only way, well, the easiest way to import tables from Excel into QGIS is to convert them into CSV in brackets MS-DOS. Okay. If we do it in CSV Macintosh, it won't work. And if we do it in CSV, the generic one, it might work or not. Okay, what I'm 100% sure is that in CSV MS-DOS, it will work. Okay, it will read properly whatever you have entered in your tables. So let's open a new project. So you may want to save your first layout. So just click, put it in the location you prefer, and then we open a new one. Okay. Go to layer and add delimited text layer. This is this icon. You will find the icon in the menu on the left side with the comma. Did you find it? Yes? So I'll click on there, and then we browse to find the table we want to add. So we go to Module 2, Layers, Household Locations, Household GPS 4326. And once we have loaded or selected the table, we just need to, well, it might recognize automatically where the coordinate, which is the coordinates field and which type of format. But in case it doesn't do that automatically, you might need to select CSV in the file format. You might need to select which fields correspond to the longitude and the latitude, and then you just click OK. And you have your points displayed on the map. So I'm doing it again in QGIS. So I click on Add Delimited Text Layer. I browse into Training Material, Module 2, Layers, Household Locations, and then there's a Household GPS CSV. Okay? So I just click on there, and I have my points there. Sometimes it will ask you in which reference system are those points. When we are using other CRS than the common ones, you will, if for the program the coordinates like looks weird, it will ask you, hey, in which coordinate system are you using? Okay, it will ask you in some of the cases, I don't know, did they ask you in which coordinate system were the points? And you put 4326. We usually, in GPS data collection, for example, in tablets and smartphones, there's no way to change the reference system, okay? You get the points in 43 and WGS84, okay? In GPS, there's no, since they are points, there's no point to complicate your lives using different coordinate systems. Then once we are in GIS, we can reproject and we can change to use a more suitable projection system. Okay. Then once your GPS data is imported, so you can use local grid, equal area reference system to calculate areas, or calculate distances, calculate trajectories. It depends. There is no a perfect reference system. Okay, the reference systems that are good to calculate areas, they distort the shapes. the reference systems that looks nice with the satellite images in Google Maps, they are very bad to calculate areas or distances. So there's not a perfect coordinate system. Okay, for point location, there's no problem. Okay, because it's just points, so there's no distortion. Okay. And the second one, at this stage, what we have is not a shapefile. It's not a proper layer. We have a table that is being read by the software, and at the same time is drawing the points. But if you try to edit, or if you try to add attributes in the attribute table, it won't work. Okay? Because we'll say it's a temporary file. It's not a shapefile. But what we need to do is to save the points that we have imported, save them into a proper shapefile. So we just need to go to here, right-click, save as. We're sure that we are saving in a SRI shapefile format, and then we just need to go to Module 2, Layers, Household Locations, and then call it, for example, Funafuti Household Locations. Okay? And by doing this, we already have a proper point shapefile. Okay? So we know already how to save, and indeed, if we want to convert those points into a local grid, for example, we are in Fiji and we want to convert those points into local grid, we use that, we save as, we change the coordinate reference system, and we will have the points projected on the reference system that we want to work on. Okay, so now we have imported points from CAPI. That points were collected with tablets. So I exported from the server, I save it into a CSV table, and I plot them into GIS. Now from a GPS unit. I don't have a GPS unit, I prepare the typical file that you get from your GPS unit, okay? So GPS, the recreational GPS units like Garmin ETREX, now there's no need to have an extra software to be able to connect. It's just plug and play with a USB cable, and the format they deliver, it's GPX. So we're gonna open a GPX file. So go to the file, Module 2, Layers, Household Locations, and it's called Households from GPS. .gpx. So we have to go using the. We need to go to because QGIS is not able to read from the add vector layer, so we need to drag the file into the interface like this. So I go to Module 2, I make this smaller. Okay, I go to Layers, Household Locations, and then it's GPX, this one, okay? And it's just a matter of dragging the points, and then you can select all if you want. So I think I have it here step by step. So once you drag it into the interface, we just select waypoint, and then click OK. Okay. So once I have dragged and I get this menu open here, I select waypoints and click OK. And you will say, where are my points? Well, these are not points from Funafuti. So in order to zoom onto the layer, okay, we select household from GPS waypoints, we click, right click, and we click on zoom to layer. It will bring you straight forward where the shapefile is located. Okay? And we have here a cloud of points, but we don't know. So what these points are. Where are these points? You can put, for example, a Google satellite backdrop on the map, and then you will know, or more or less, because it's not an easy place. What is this? Does it tell you anything?
Where did you get your Funafuti?
Huh? Sorry.
Where did you get your Funafuti household?
How did I get them? Because I when I was saving them, I put that name.
Okay.
What is this? Any idea? Come on. The people from North Pacific? Huh?
The household has been enumerated.
Yeah, but which country is this? Yeah. No one? No, this is not Tuvalu. Tuvalu are these ones. This is Tuvalu, but the other ones, we have no idea. Well, I know because I prepared the exercise, of course, but it's Marshall Island. Sorry, it's Northern Mariana, CNMI. No, it cannot be because. Okay, maybe you invaded another. No, it's Northern Mariana. Okay, but a good way to know where these points are coming from, Google Satellite. Well, if you use another, we could use maybe humanitarian, and maybe we have some labels here. Doesn't want to work. Well, okay. So we have already imported from a CSV table. We have imported from a GPS unit. Now we have the points from Funafuti. What I will ask you is to open a new project, or if you prefer, well, either open a new project, or if you prefer, just remove households from GPS, remove households GPS. The one it's, well, I think it's easier if we open a new project and we start from scratch, okay? Because we might keep the wrong shapefile, etc. So we open a new project, we can discard because there's nothing, we're gonna repeat the same process. So now that we have stored the CSV table as a shapefile, I want you to open that file, okay? So in household locations, I did call it Funafuti. Open. Okay? So we're going to learn now how to modify points. We can have some points that are in the wrong location. Don't know. We just, so as I was saying before, when we have CSV points, we cannot edit, we cannot modify anything. But since we have a shapefile, we can start modifying our dataset. So to start editing, okay, we just right-click on the layer and select Toggle Editing, or for me, in my opinion, the easiest way is to find this icon with the yellow pencil. But first, we have to be sure that we are selecting the point layer. Okay? So, I repeat. I go here to my Funafuti locations where there's only one shapefile. But when we have multiple, we have to be sure that we are selecting the right one. So, I select Funafuti and then I click on this yellow pencil icon. Okay? And you will see that my point, the point I had here, it's replaced by the point with the pencil above, okay, on top. So the icon for the layer we change from point to a pencil, and then with the digitizing tools you can add, move and remove points. Okay, so we can do several things. Okay, we can play with this data set. Okay, so for example, I'm gonna zoom in a little bit more. Maybe I'm gonna add the Google satellite image and put it on the right place in the layer panel. Okay, and for example, I have seen that I have a point here that has a wrong location. It should be here. Okay? Now I'm on editing mode. So I can move my points, selecting this tool, move feature, the one that has 3 points with a blue arrow, and then just I click on the tool and then I just select and move. So I have to click on them and then I can move them. Okay. The other option, and the option I use the most because I don't like that move feature tool for points, is to use the node tool. Okay. With the node tool, we can. The node tool is this one. It's a bit hard to. It's this tool, okay? This one that appears a vertex here with a hammer and a screwdriver. Well, it's hard to, but well, this weird icon here that I don't know exactly. Actually, it's the first time I pay attention about what the icon means, because in my computer they are so small that I was okay, no tool, but I didn't know. But well, however, so with this node tool activated, you will see that if you click on your point, it will become like it will be surrounded by a red square. Okay, so you just need to select it, and then once it gets blue, you can drag it wherever you want. Okay, at the same time I can drag it, and if I click delete, I first have to click on the point in order to get the square turned in blue, and then I just click delete and I remove it. Easy. But if I want to delete several points at the same time, I just need to select like this. Oh, no, I can't. Well, you have to just do it one by one. Actually, it works different from the polygons. Okay? Or if you want to remove several points at the same time, you have to use the select tool, which is this square, yellow square, and then you just select several points. They are highlighted in yellow, and then, oops, I kill all the points. You can go back with a Control Z or undo if you don't want to. If you want to go back, okay. Once we have finished with all, so we know how to move points. Have you tried? Did it work? Have you tried to delete one, two, several points? Several points. Don't be shy. Let's kill the points. It's no. So it's not census, okay? Yeah, let's kill let's kill Tuvalu's data set. Yeah. There's no backup. Yep. You can either go to undo here or Control Z, as in Word, Excel. Okay. So you can erase, but you can go back, Control Z, but once I save my edits, you're done, okay? You kill it, okay? There's no way back. So make sure that this is a common advice, okay? Well, now with the email, most of the shapefiles, they send you by email or something like this. So at the end, you have kind of a backup, okay? But the right way to do is like you get your shapefile, you open it, and you think, okay, do I have to do any editing on that? Because the stuff we have been doing, changing the color, changing the labels, the boundaries, we are not doing anything over the file. Okay, we're just changing the way the shapefile is displayed in the map. Okay, but nothing is changing in the file. It's just the way it gets displayed, and it's controlled by the project. Okay, but once we start editing, so we move points, we modify polygons, we delete, we change codes. Okay, we are editing. Okay, so do I have to? I'm starting to edit. So the reflex in my case is I save a copy. I call it backup, or I call it before I do something stupid, okay, I save it, and then I start editing, okay, because in the case you erase a polygon that you shouldn't, or a code, or a field, you always have your backup, and then you can recover whatever you've lost, okay? So last one, how do we create a point? Because imagine that I have some points missing, and some guy from education is telling me, okay, he has no GIS background, but he knows where the schools are. So he's gonna sit down with you and tell you over the satellite image where the schools are. Okay, well, this is households, but so it's just, we will click on, to create a new point, we will click on this icon, okay? So I click on this icon here, that it's called add a feature, which means that I'm adding lines, I'm adding rows in the attribute table, okay? And then I just click, don't know, here. So, and then once I make the first click, I have this information that I have to fill, okay? This is the ID, which EA, which unit, is this household occupied or not, which is the household head of the household sex, number of males, number of females, population, tenure. Okay, so I just add some stuff, and that's all. And I'm adding new points. Huh? Well, if it's I'm just using random, and actually I'm adding ID, yeah, but it doesn't detect. This is something that you have to detect yourself. There's no a rule in shapefiles that doesn't. It's not like in a database that there's no key ID. If you work in a geo database, you can set that you have a key ID, and you have a rule that does not allow you to have double duplicates IDs. Okay, but in a shapefile, there's no way to control that.
But there is no rule to disallow it.
No, there's a rule to detect duplicates, but there's no rule. There's no this like in Access databases that you select the key ID field, and when you enter a duplicate, it tells you no, you can't, because there's already a household with ID code number 1. Okay? So now we know how to create a point within a feature, we know how to delete points, we know how to drag points. Okay? And I save. So in this case, my backup is the CSV table. Okay, I can re-import the points from the CSV table and convert it into a shapefile and keep working. Okay, so I think that this is, well, just the last one, okay, that I was, yeah. So, and then how do we, now we are in editing session, okay. Are you familiarized with attribute tables? Yeah. So, in QGIS, we access to attribute tables here in Open Attribute Table, okay, or by selecting the layer in the Layers panel and clicking on this table icon, okay? So this is all the information from a listing, okay? But it has been randomly modified. So the locations do not correspond to the real data. Well, there's no name of household, so there's no. Okay, so this is the typical information we get during a household listing. Is the household occupied or not? How many number of males, females, total, tenure, okay? So this is the typical data. So when we are on editing, we can modify those parameters. Okay, we can modify, we can delete fields. Okay, I'm gonna share this data with someone, and I don't want to share tenure. So you can erase the field. You can create new fields that you're going to populate. For example, you can create a field which is going to be the unique ID for the household. And, or you can just modify the number of males and say, no, there's no 0 males, there's 5, and here there are 4 females. So the total are 9 females, okay? So you can modify from the attribute. At point level, I would recommend to just use Excel, but sometimes when we are working with polygons, the codes and everything, it's quite handy to work with the attribute tables. Okay, and because well, Excel it's much easier. So let's. Have you managed to open the attribute table? So, for example, in regards to your question, Arnold, we're gonna create a unique ID for each of the households. Now we are in editing session with the table. Okay, so just follow me. Okay, because this was not in the presentation. Okay, so we're gonna use in ArcGIS there's a field calculator. Okay, here in QGIS, one of the I think that probably the field calculator is one of the things I like the most in QGIS, because it saves a lot of time and it's super user friendly once you once you get used to. So we are sure that we are in editing mode. Okay, so let's click on the field calculator, this icon here that looks like don't know, these calculator machines that use the Egyptians. I don't know how it's called. Abacus? Don't know. Well, abacus. So, and then we are in editing mode. That's why we have this option here, create a new field. Okay, so let's add a name. Okay, we're gonna create a field that is called key ID. Okay, it's gonna be a number. So we can, if it's gonna be a string, if it's gonna be the name of the head of the household, we will select string. Okay, but this is something I think we're gonna go through later on. But for the moment, just to show you quickly how the field calculator works. So, and output field length. In FUNAP Footy there are less than 100 million households, so with 10 characters it's gonna be more than enough. Okay, so, and then we have here some expressions. Okay, expression is the good name. So we're going to go to record. Okay, you have to go down. You can use this slide here or just using and you will find record. And we have many different options here. So we're gonna select this ID just by double clicking ID. Okay, and you will see that output preview says that you have 0. If you don't have an error, that's good news. Okay, and that your OK button has been activated. If I have nothing in the expression, I cannot click OK. Okay, and if the expression is wrong, I cannot click OK. I will have, if I put something like this, well, because it's gonna. But if I put something wrong, it won't allow. If you put I always put wrong expressions, and I cannot recall an expression that. So equal, for example, equal. It gets expression invalid. Equal to what? So this is not allowed. So I cannot click OK. Okay. So just double click ID and then click OK, and I have on the right side of the attribute table a key ID, a unique ID for each of the households. It's been 3 clicks and I have created an ID code for each of the households. Then you can, this ID code, you can merge it with the EA code, for example, but this is so. But with the field calculator, you will see that we can do many complex things, and So, and the best, if you say, okay, I want to generate, if you think, okay, with the field calculator, I want to do something like create, this is something that we're gonna do, create a field that rules the orientation of my map layout. You just need to Google it. I didn't invent anything, okay? Everything that I'm showing you in this training, I got it from Google. It's true. So it's something that it's by the fact that you're working on GIS and you're trying to improve and you're trying to learn, you just Google it, okay? So you find nice expression. Oh, this is this. So with the field calculator, we can do many complex things that can save us a lot of time working, okay? So we have generated we have made something easy, that it's create a key ID, a unique ID for each of the households, but it's been 3 clicks. Another option is to take the CSV table and create the right type 1, 2, 3, drag down and import into the GIS. There's many ways to do this, okay? But and it's good we don't get blocked, we don't get stuck by saying, okay, I cannot do it in QGIS. If there's something that you cannot do it in QGIS with tables, let's export it into Excel, do whatever you know, because you're more familiarized with Excel, and then you bring it back to QGIS, okay? So with this, and if you want to keep your key ID, don't forget to save your edits, okay? Last tip, there's a big difference. There's a difference between save edits, here, this disk with the red pencil. This is to save edits within the shapefile. When I'm saving here in the project, if I don't save the edits, it will tell me, well, actually I'm gonna show you 12, okay? I'm not saving. So if I save here, test, it allows me, but I'm not saving the edits I made on the shapefile. So, but if I try to close, I have this message. You want to save the current project? Yes, I do. Project has layers in edit mode with unsaved edits. So it's different. So the project rules manage the way, just that, the way the layers are drawn, the way the layers are displayed, the color, the labels, the map composer, okay? Just that, the project. So when I save my project, I'm saving my map composer, I'm saving my enumeration area shapefile with orange borders and transparent fill, labeling EA codes with blank with white buffer. That's all. But I'm not saving any edit within the layers. So when I'm modifying polygons, there's no point to click on save, the save button in the project. I have to save here. I have to save my edits because the project does not control that, okay? I open an editing edition, I make my modifications within the attribute table, the geometry, etc., and then I save my edits, okay? And the project just for the display mode, okay? We're going to layer, new shapefile layer. We will have this menu to fill the attributes that are gonna populate our attribute table. We select Polygon, we select the right coordinate reference system, and then we add the name of the fields and the format of those fields. And well, by clicking here in Add to Fields list, and then once we have created our polygon layer, we'll see that there's nothing there. Why? Because my attribute table, if you go to open attribute table, it's empty. There is nothing there. Okay? So what we are going to do now is to create a polygon. The same way we were doing yesterday when we were creating points, we're going to do the same. Okay, so we have to open our editing session, clicking on the yellow pencil, and then go to this control, Add Feature. You will see it's like a kind of a green polygon with a yellow star on the right bottom corner of the bottom. Okay? So, if I click there, you will see that my cursor has changed. Okay, and now it's like kind of well, has changed. So now if I can delineate a polygon like a enumeration area, like doing like this. No, for example, I'm gonna make something weird, and then once I have finished my polygon delineate the polygon delineation, I just click on right click and I have a menu a menu screen that asks me to fill the field, so I can say, well, just number 1, and I generate the polygon. Okay. Then if I want to delete the polygon, because this is not a proper EA polygon, it's just a draft, just to test the tool, I can go to Selection Tools here, go to Selection, select Features, click. In the feature, we see that it turns yellow, like the points yesterday when we were selecting them, they were turning in yellow, and I just either I click on this bin icon, or just I use the delete key and I can delete it. Okay, so but now we want to delineate proper enumeration area polygons. So what we are going to do is try to follow, try to create nice boundaries. Okay, so the idea is to use, for example, roads. Okay, Funafuti is tough. Funafuti is a complicated city to do this. But for example, we can use these roads. So I'm in selection mode. So I'm gonna click again in create new feature. So and now I'm going to, for example, I'm going to create this polygon here, this enumeration area, where my enumerator is going to be quite happy because it's quite easy to find the limits. Okay, so I'm just left click on my mouse, following the street, and then once I'm happy with the shape, with the boundaries, I click on right click, and then I have the panel, okay, where I have to fill the information, the EA code, which is, well, this is gonna be number 1. Okay, we have digitized our polygon. Then you can change the style. You can put a transparent fill, select a nice color for the boundaries that have enough contrast with the satellite image in order to work in a better way. Okay. Okay. So this is our new polygon. So when we want to add new polygons, it's important that the boundaries matches the boundaries match with the other polygons boundaries. We don't want to have overlaps. We don't want to have gaps. Okay, but if you try now, when you are creating a new polygon, to snap to stick your vertex to another existing vertex manually, I tell you, this is never gonna happen. Okay, it's impossible to snap a vertex manually, never. Okay, I'm gonna show you. Okay, I have 10 years GIS experience. Okay, so I'm gonna create a new polygon. This is my polygon number 2. Let's change the style. And imagine that so can you see the polygon? I'm gonna increase the okay. So this is, you see the red cross? That's which are the vertex. Okay, so I'm still in editing tool, and I'm going to vertex tool. Okay, and I'm gonna take this vertex here, and I'm gonna snap it manually with this one. Okay, how does it look like? It's a snap? No. So if I'm zooming, oh no, it's not. Okay. It's a zoom, but I can try to do my best here, like, yeah, I'm gonna get it, and it won't never happen. Okay, we can go to millimeters scale, and we will still like trying to make the coincidence between both vertex. Okay, so there's a tool that works like as a, I call it, because I like the comparison, like a magnetic field that help us to bring those vertex together. So when you're close, the tool just snap it automatically. Okay, but we need to learn how to configure that magnetic field, because we don't want to be we don't want to have this attraction too strong, because we are not going to work properly, or we are not going to be free to move the vertex, and we don't want that it's too weak that we have to zoom in, zoom out all the time to stick the polygons together. So this magnetic field tool, it's called snapping options. Okay. And we can change the settings in the snapping options, going to settings on the menu bar, snapping options. So settings, snapping options. Okay, and we get this this menu here. Okay, and we have different modes. The layers we have. When we open the snapping options, we have here the layer selections, which is either current layer, the layer that I have selected, the layer that I'm working on, okay, or you can click on advanced. My recommendation, use all the time the advanced mode, okay, because we can display the snapping options for all the layers in my project, okay. And sometimes when we are editing different layers at the same time, it's good to be able to activate, deactivate the snapping options, okay, from the different layers. So here we are. So we go to advanced, and we see that we are working on the test polygon, okay? So I check here, like which means that I'm activating the snapping option. I'm activating the magnetic field for that layer, and in mode to vertex and segment, I want my vertex to get a stick on the lines between the vertex and over the other vertex. The tolerance for this case, we can use pixels. Okay, this is a bit tricky because you have it's a test and error. Okay, we are now. It's going to depend on the projection that we are using in our project. If, like in this case, we are using decimal degrees, 4326 is a decimal degree. A decimal degree is 110 kilometers in the equator. So it's 1 decimal degree, it's long distance, 100 kilometers, roughly. So if I say that my tolerance is 1 map unit, it means that if my point is at less than 100 kilometers from the other point, it's going to be a stick. So there's no way to move a point in our map. So look at this. So I'm going to show you. Okay, I say like, okay, my polygon, my tolerance is going to be one map unit, which is a 1 decimal degree. Okay, I'm trying to. Okay, whenever I try to move the point, you see, it's a mess, okay, because it's too strong, so I cannot drag the point freely, okay? So what I'm gonna do is to reduce the tolerance, okay? Reduce the intensity of the magnetic field. So I stick on 0, so I say, okay, 1 degree is 100 kilometers, so let's say that it's 100 of meters. Okay, and now I can move freely my point, but at the same time, when I'm close to the other vertex, clack, snap the vertex with the other. Okay, this is a test and error. It depends on the scale of your map. If you are working with a huge enumeration area in Vanuatu, you will need to increase that tolerance because you want to have more intensity. If you are working in Funafuti with very small polygons, you have to reduce this snapping strength. Okay. So, but for this example, not to get confused because it's our first approach, I used, instead of map units, you can select here pixels and set 10 pixels. Pixels is the universal unit for maps. Okay, it depends on your screen. So it doesn't depend on whether our reference system is in meters or in degrees, because on the other hand, if my reference system is on meters, on this case, if I put 0,001, I'm talking about my millimeters. So I have to zoom a lot to get my point attracted by the other. Okay, so if it's in meters, we will use like 10, 15, 100 meters. Okay, but when it's in degrees, it's hard to remember how many kilometers a degrees is. Okay, so just set the snapping options like this. So we click on text polygon to vertex and segment 10 pixels. Okay. And then we click on this avoid intersection and enable topological editing. What it is for, this enabling topological editing? So if I have this, for the moment I don't have it. I didn't check that option. Okay, so once my vertex is a stick to another vertex, I can split them, okay? But if I select this enable topological editing, once I have two vertex from different polygons together, now they move together. And this is very handy when we are editing boundaries, because we don't need to move to vertex. We just move the common vertex, and the boundaries are going to be modified automatically. So depending on what are we doing during our editing session, we want to have this topological editing activated or not. Okay? So, and I'm creating what is for the option this avoid intersections, okay? Because if I am creating an additional polygon and I click and I select this option, avoid intersection, okay? Imagine that I'm gonna create this polygon here, okay? If I don't have this activated, I should be doing this, like one vertex, okay? And then, so carefully make the vertex, well, draw the vertex over the other vertex. It's helpful that because I have this magnetic field, okay? But if I have a boundary where I have 250 vertex, it's still too long, okay? It's still painful. And so now it would work, okay? But there's a faster way to do. So now, since we have this avoid intersection, when I'm editing, this feature doesn't allow overlappings. So I can draw roughly my adjacent polygon like this, okay, and then keep going with the boundary, and then when I stop editing, it just crop the boundaries using the other vector. So you see that this and this, they match perfectly. So it does, whatever it's overlapping, it just ignore it. Okay? So this is very handy because once you have properly delineated your first polygon, you can continue well, you can work faster. Okay? So let's go back to the. So this is the snapping tool. Okay? Just a couple of tips on when we are editing polygons. Okay? For example, with the node tool, you have seen that we can drag and move vertex, okay? But at the same time, with the node tool, when I'm activating, imagine that I select this polygon, okay? And for example, well, I can, as I show you, I can drag the vertex, which, and I do this like selecting the polygon, selecting the vertex. Once the vertex is in blue, I can click and hold, and I can drag the vertex to its new position, okay? I can do two additional things with the vertex tool. One, create a new vertex. How do I create a new vertex? Easy. I put my cursor on the segment and I double click. Double click, double click, double click. Like this, I can reshape my polygon. I don't need to create it again because, oh, I didn't follow, I didn't generate enough vertex. So I can add new vertex to improve the quality of the boundaries. And at the same time, I can delete vertex. Okay, I just need to select them when they are turning to blue I click delete, or I can select multiple vertex like this and delete them. Okay, so I can drag them, create them, and delete them as we were doing with the points yesterday using the node tool. Okay, so we don't need to recreate, or we don't need to be very worried about how did we make the first delineation. Okay, we can refine the shape of our polygon afterwards. And this is very useful when we are cleaning topologies. This is something that I'm gonna show you a bit later. So, the snapping tools. How do we deal with borders, with the limits between enumeration areas? Now, I'm gonna show you, I think, two tools that we usually use when we are working with EA frameworks. First, split. Cut the EAs into two pieces, okay? Because sometimes they say, okay, for the next census, we have realized that one of the EAs is too big, and instead of sending two enumerators, what we do is we update our EA framework and we divide those EAs into two smaller polygons. Okay, so how do we split a polygon into two pieces? Okay, first we go to we need to have this advanced digitization toolbar activated. If we cannot see this toolbar in our toolbar, we have to go to View Toolbars and select Advanced Digitization Toolbar, and as well Digitization Tools, in case it's not there. I think that Digitization Tools, it's displayed by default. So we go to right click here, okay, and I see toolbars. So I need Advanced Digitizing Toolbar activated, okay, which is this long toolbar here, okay. So first of all, before we do anything, please save your changes. Save your changes in the editing, okay, the disk with the red pencil, and save your changes in the project, because if not, any change, any style, any label that we have added, it won't be stored if we accidentally close the project. So then we have our Advanced Digitizing Toolbar there in the top menu, and we click on this button here. Okay, when you put your cursor on the button, it's called a split feature, and just next to this it's a split part. There's a difference, but I will explain that later, but we are going just to split feature, okay? Then to split, we need to delineate a line that is going to define the boundary between the newly EAs, okay? So what we have to do is to first click outside the EA and then trace the line crossing the EA, and then click, our last click, it has to be outside as well of the EA. I don't know if you see well. So I will start where the red arrow is outside my EA. I follow the road to make the split, to make a nice border between the new EAs, and then I click here I have to get out from the EA. And then I right-click, and it's done. It's a bit tricky, okay? It takes just a few tests to get used to, okay? But it's important. We start outside, and we finish outside, okay? Now, to merge, which is much simple. So now imagine that we made a mistake, and we have split wrong EAs, okay? So what we're gonna do is to select, sorry if the buttons are in the wrong place. We use the selecting tool, and we're gonna select the two features that we want to merge, okay? That we want to join, that we want to, to convert into only one EA, okay? And then once we have selected 2, 3 EAs, we click on this button here, which is the merge tool, okay? We select, we click on merge tool, and then we will have a new window with, now we're taking 2 rows with different attributes. So we need to select which of the EAs, which information we're gonna keep on this new EA. So we just we select the attribute we want to keep. We click on take attributes from selected features, and we click OK. Okay, so I'm gonna do it in the software. So now I'm gonna make a split like this, okay? And now I want to merge them back, okay? So I'm going to first, if I have anything, if I have nothing selected, my merge tool won't be activated, okay? So first of all, I have to go to selected tools, and we have several options. Use the rectangle to select, or we can use Shift and select. So we hold Shift and we can select several ones, okay? Then you see that once I have 2 features, 2 polygons selected, my merge tool is activated. Then I just need to click on it, and then it tells me, okay, which attribute do you want to keep? Okay, so I say, okay, I want to keep this. Well, in this case, it's the same attribute, so there's no problem. But we can select which row we want to keep. And then once we have done this, we say take attributes from the selected row, and then we just click OK, and we have merged the EAs back. Merge process is much easier. It's less tricky, okay? Because it's just select, click on merge, and we're good. And select the right line, okay? So one of the nice things, one of the nice features of QGIS is that it's like he can handle with many different type of spatial files formats, okay? We can, before the ones of you that have worked with map info and ArcGIS, it was very hard. So you had people working with map info, producing new files, and if you were working with ArcGIS, the formats were not compatible. Okay, you need to pass through another software to export, but it was hard. QGIS can work with Shapefile, map info format, KML, whatever. Okay, it's like a Swiss cat, you know, that you can use to import and export from one format to another. So it can handle a wide range of spatial files, okay? Oracle, MySQL, Spatial Database, PostGIS, Spatialite, Grass, whatever. And the more they improve, the more they update, the more format we can handle with, okay? So it's not something restrictive as they were trying with ArcGIS or Map Info. So I keep my spatial files format, and this is the only one you can use. And if you want to use another software, let's convert it into another. So this is another approach. Okay. So which is the most common type of file we use in GIS? Well, this is gonna change soon, maybe not. We'll see. But for the moment, it's shapefile. Okay, for vector. Okay. But a shapefile, it's when we open a shapefile in our GIS interface, we only see one file. Okay, but when we go to Windows Explorer, we will find this. If we are working in QGIS, we will find these five files extension. Okay, and when we want to imagine that I want to share a shapefile with a colleague, and I'm sending the shapefile via email. If I only send him this, the .shp, my colleague is not gonna be able to open it, okay? Because we are missing information, okay? A shapefile, when we have a layer open in our GIS software, the GIS software is retrieving information from these five files. Roughly, the .shp stores spatial data. The DBF, it's the attribute table. The SHX, well, it's a file to improve how fast we are retrieving information. It's like an index in a database. Well, it's something that we need, okay? And the PRJ and the QPJ formats they contain projection information, okay? They contain which reference system are we using, which type of units, etc. Okay? It helps the program to locate where our polygons, where our GPS points are in the map. Okay? So we have shapefiles, and then we have the project file. Okay? The project file, it's just a text file where the software is noting what we are loading. I'm loading a shapefile that it's called GPS household location South Tarawa 4326, which is stored in C drive GIS training module 4 layers there. So you have the paths, the routes, but it's just a text file where it's storing all this information. And the layer has red borders and transparent fill, and it's on top of the layer panel. I have as well a Google satellite image, and I have as well a point layers with a household ID label. The project, the only thing is it's listing what is happening. Okay, like this, when we open again our project, we don't need to load again our shapefiles, reset the styles. Okay, so it's something that it's keeping that type of information. But if I share with a colleague the project, okay, just the project, he won't be able to display anything, because we are not providing the shapefiles or the other components that come with that project. Okay, my colleague, even if he has QGIS software installed, he will click on the project And the project will start like, okay, I have one shapefile in this path. He will try to retrieve in your colleague's PC, and he won't find anything. Okay? So it stores shapefiles and raster location, other files like tables, like images, information about our map composers, which items, the scale bar, the text, the legend, the different maps. Okay? The other these layers are displayed. So for example, and I wrote here at the end of the slide, try to open one of your .qgis files with a text editor, and you will see that it's super simple. Okay, it's just so let's do this, and we can see the different elements easily. So if I go to, for example, in module 5, we have a huge project that we're gonna use on Friday, and I open it with my text editor, and I'm gonna, okay. You see that here, for example, we have layers tree group. Okay, so I have where's the name of this layer? Well, this is QGIS project name. Layer, the layer must be there, the layer name must be there, This is the path, you see, training, module 5, layers, and then the name is selected survey, and this is for all the layers that are in my layers panel. If I go a little bit down, I see map canvas. Unit, which units? Degrees. Which projection? Projection, datum, WGS 84, okay? And then the different projections that I'm working with, okay? Then this is more about projection and reprojection, etc. And then other layers. I have, this is for the layout, for the map composer. So what I have, a legend layer. Okay, composer. What do I have? Symbol. So all the information that. Do you remember yesterday in the map composer that we were like in each of the item menu? We were like the type of font, the size of the font, the size of the map canvas. Okay, all this information is being stored as text. Well, the project is just writing down that in a text file, and then when you open your project, it reads very fast, though it reads and loads everything you were working with. Okay, but it's just a text file. There's nothing in there. So if we want to share a project that with a colleague and we want him to have access to those shapefiles, we have to share those shapefiles at the same time. And which is the easiest way to share that that material, okay? All that, the project plus the layers. It's just, for me, the simplest way to share a project with some colleagues is the way I have used with you guys. You will see that if you open a project in module 5, that it's a very complex project, you will double-click on that project, and it will be able to retrieve all the layers, because I have my project file here, okay, and below I have a folder called layers. So the project is used to change the location. Maybe your drive is not called C, it's called D, okay. Maybe you store your information in a folder called QGIS instead of GIS. But since the project what it's gonna do first is to try to find below, and if he finds the same common route, the same common path, okay, for the last folder, it will be able to retrieve the data. Okay, so if we want to share project and the layers in the same folder, below. Okay? And then we zip all that together. We send by email, we share in Dropbox, and he will just need to unzip, double click, and everything will be open. Okay?